What's going on, Fiveable? This is Shane with statistics. Super excited to be here to help you score better on the AP exam. Once again, my name is Shane. I'm going to share my screen with you so we can dive into it. Super excited to have you all here. Today we're going to dive into our third session, which is all about the normal distribution or modeling data or describing data in a distribution. If you didn't watch the last two videos, I would highly suggest you go back to go check those out because those are going to be really beneficial to accessing this chapter that we talk about. We're going to do a lot of the stuff that we did last chapter because it's necessary to help us access this chapter. So like I said, my name is Shane Durkin here with Fiveable. Super excited to help you guys out. As always, I go live Thursdays at 5 p.m. Pacific Standard or 8 p.m. Eastern Standard Time. The first three major topics that we covered this year: exploring data, designing studies, and the normal distribution, which are usually the first three chapters, depending on what book you use. As always, with me, you're going to get lots and lots of helpful tips to help you score a 5 on the AP exam. I actually had a student yesterday come in who's going to UC Santa Barbara, and she got a 5 on the AP exam. She was talking all about how helpful this class was for her, and she's going into marine biology and studying statistics as a double major, and she feels very prepared in those classes. So I hope you can get the same out of this, and I hope you find a love for statistics like I have. We're going to cover exam tips, FRQs, and multiple choice, calculator tips, lots of calculator tips, and a lot more. So let's dive right into it. So the normal curve, this is where we're going to start with today. This is kind of a shorter chapter than usual, but it's kind of the basis for moving forward, especially when it comes to probability, which is most likely going to be your next chapter or the one after that. So the normal curve, we got some big topics today. Here are the big topics. One is percentile. So what is a percentile? Second is a cumulative relative frequency graph. This one always takes me a minute to actually say because there's so many big words there. But we're going to break that down so you know exactly what that is. And every now and then we do see one of these on the AP exam, particularly on that free response section. In years past, I've had students from other schools come to me and they totally forgot what a cumulative relative frequency graph is. So we're going to talk about that today. We're also going to cover standardized score, or in statistics, we call that Z-score. Super, super popular. It's going to follow us throughout the whole year. So we're going to spend lots of time, not only during this session, but in future sessions, talking and using Z-score. And last but not least, transforming data. This isn't a huge part of the AP test. There's probably 1 to 2 multiple choice questions on it. And very rarely do I see a free response question on it. However, it's good to know just to make sure you get those couple questions right on the free response. All right, so we're going to dive into the first topic, which is percentile. So we're going to dive into percentile. Here's just the basic definition of percentile. So if we were to take the P percentile of a distribution, it's the value with that much percent of the observations less than it. So for example, if I wanted to know the, let's say the 15th percentile of a distribution, then 15% of the observations are less than that number. Now I know it might maybe still a little abstract, but it's actually pretty straightforward, and we're going to go over some examples together. So here's an example of a percentile. So let's say I gave a test, and it was to my Algebra 1 students, and here's how they scored. I have one student who got a 86. Remember, this is a stem and leaf plot. So if you weren't here the past 2 sessions and this doesn't look familiar or you're kind of unsure about it, make sure you go back and watch those other sessions, particularly around the stem and leaf. So this is a stem and leaf. Remember, this right here represents a score of 67. This here is 72. So if I gave this algebra test and I wanted to know the student who got a 68 which is bolded in black right here, how did they score relative to the rest of their class, or what was their percentile? So here's how we would do that. We would take the total number of data points, which is 25, and since 86 was the 21st, we would take 21 divided by 25, and we would get 84 as our percentile. Now, there may be one or two multiple choice questions about percentile on the AP exam. Not as many as you may think, but there are probably going to be more on your chapter test in your class, so it's good that we know it. So again, it's pretty straightforward. You just take the total number of data points, put them in order, find your data point, and take your data point divided by the total number of data points. So this person scored in the 84th percentile, which again, doesn't mean they scored an 84 on the test, because we could see they actually got an 86. What it means is 84% of the data falls below there. Or in this case, 84% of the students scored below what this student scored. Some students get percentile and percentages mixed up, so it's important to keep them straight. Last thing, don't overthink percentiles. It's pretty straightforward, similar to what you might see on like the box plots when you see Q1 or Q3. Again, that is a percentile. So let's go over a couple multiple choice questions just to make sure we kind of understand what exactly a percentile is. So here is the first question. If I tell you that you scored a 50 at the 55th percentile on your final exam, you would know what? A, 55% of the class scored as good or worse than I did. Sounds pretty good, but we're going to move to the next one. I earned a 55% on the exam. No! Remember, this is kind of what we just talked about. Just because you scored in the 55th percentile doesn't mean you scored a 55% on the test. Does not mean that. So that one's wrong. I failed the exam. We don't know that. You scored the 55th percentile. We don't know if you failed or what you scored on the actual exam, so we cannot say that either. Or 45% of the class scored worse than I did. Nope, that's kind of the complement of what's here. So our best answer choice is going to be A. 55% of the class scored as good or worse than I did. Once again, if you have any questions during this, please ask. I find when students ask questions, that's when I can dive deeper into the topic, because you probably bringing up a question that someone else has, and I can answer that question in a way that maybe leads to another answer for another student. All right, so that's our first multiple choice. Let's dive into a second one. The 75th percentile is also known as the blank. So 75th percentile is the third quartile. That's going to be right here, letter choice C. Remember, the median is going to be the 50th percentile. The first quartile is going to be the 25th percentile. And the interquartile range is just going to give you a range between the 75th percentile and the 25th percentile. So it'll give you that middle 50%. So once again, the median is the 50th percentile. The third quartile is, the median is the 50th percentile. The third quartile is the 75th percentile. And the first quartile is the 25th percentile. Let's move on to our next multiple choice. Again, at any point, please stop and ask a question below. Given the data set, 1, 2, 3, 6, 9, 11, 45, 102, calculate the rank for the 11th percentile. So we want to know where would the, what percentile would you be for number 11? So this number right here, what percentile would they fall in? So once again, you want to count up all your data points. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 different data points. 11 is going to be the 1, 2, 3, 4, 5, the 6th data point. So we're going to take 6 divided by 8, and we'll get our percentile. So 6 divided by 8 gives me the 75th percentile right here. So it's actually also our third quartile. So the answer should be D, right there. Pretty straightforward. Again, that might be a question on your AP exam. Probably going to be a question on your chapter test. So make sure you know this. We'll do one more free response multiple choice question and then dive into it. What is the 50th percentile of the following student heights? All right, so once again, we have all these student heights. But one thing you should notice is that they're not in order. We can only do percentile if they're in order. So I'm going to write down on my paper over here. And let me show you on my dot cam. So the numbers I have are, let me get that straight. We have 60, 75, 70, 58, and 62. Once again, we need to put them in order from least to greatest. So 58 is going to be first. Next is going to be 60, 62, 70, and 75. And so the question asks, what is the 50th percentile? So we want to know what is the middle number in this data set. So it's going to be right there. And here's how we could prove it. So we have 1, 2, 3, 4, 5 data points. So we want to know what's the middle number of 5. That's going to be 3. Okay, let's go back to our PowerPoint and move on to our next topic. Again, if at any point you have a question, perfect, you read my mind. Great question. So Jediah asks, let me start answering. How would you find percentile for large data sets? It's like I planted you there, Jediah. So we're actually going to get to that with z-score. So z-score is actually going to help tell us that. So we'll dive into that in a little bit. Hold off on that. All right. So we just talked about percentile. Next comes cumulative relative frequency graphs. Then we're going to dive into that z-score. So Jediah, wait up for that. Transforming data. And then we'll get out of here. All right. So cumulative relative frequency graphs. Here's the straight definition of them. It displays the cumulative relative frequency of each class of a frequency distribution. That's great. That's nice to know. But until we actually see it in practice, it doesn't make a whole lot of sense to students, I find. So let's use an example. So right here is some data from 88 teachers at a school that I used to work at. I asked them, what age were you first hired at the school? And I put them in buckets. So the first bucket was from 21 to 25, 26 to 30, and all the way down to 46 and 50. This column right here shows the frequency. So how many people responded in that age group. So you can see right here, 4 people were between 21 and 22 when they first started at this school. And it goes all the way down. And if you add all these up, they'll add up to 88 because that's how many teachers I surveyed. Over here is our relative frequency. So how many of those teachers were in that category relative to the whole data set? So when I took 4, I divided it by the total, which gave me 4.5. So, I'm sorry, that gave me 4.5%. So of the people that I surveyed, in this case, the people at my school, 4.5% of them came into teaching at this school between 21 and 25. Next, 14 of them came in between 26 and 30, which is about 15.9%. Next, 26, and so on. So that's the relative frequency. On the next column, we're going to have cumulative frequency. Remember, cumulative is added up. So as we go down our list, we're going to add what was previous to our new set. So right here, I had 4 that were from 21 to 25. If you add that 4 to that 14, it's going to go up to 18. So I have 18 teachers that were 30 or younger entering their first year of teaching. And I'm going to add the next set, which is 44. So 26 plus the 18 that we had gives me 44. And keep going until you get a total of 88. So no teacher at the school, well, this is 50 plus. So let's just pretend it was 50. So no teacher was hired at their first time at 51. Now, if you go to the next column, you're going to see the cumulative, which again is everything added up, relative frequency. So this is using the cumulative numbers, not the frequency numbers. So if you look here, that is going to stay the same because that's only our first bin, which is 4 out of 88. But then my next percentile is going to take this 18 because, again, it's cumulative. So it's adding everything up. 4 plus the 14 in this bin is going to give me 18, so 20.5%. And it's going to go all the way to 100%. Here's a helpful hint. Cumulative relative frequency graphs should always go to 100%. If it's not at 100%, something is wrong. Now let's look what that actually looks like on a graph. So I graphed it right here. On your left-hand side, you're always going to have the cumulative relative frequency. So it's that percentile. Remember when we first started from 21 to 26, remember that was 4.5%? Look at it right there. If we drew a line, it would hit about 4.5%. And at the very top, at 50, it's at 100%. It should always go to 100%. Now, probably on the AP exam, they're going to ask for you to break this down. So it might ask, like, where is the 50th percentile of this cumulative frequency? Or at what age did 50% of the people fall below the data point? So 50% is in between the 60 and the 40, which is right there. So I draw my line straight across. And I see at about 36%, or 36, half the students were younger than when they first started, and half the students were older. And we could see back in our graph that at 36, that was kind of the line, right? 44% of the, or 44 of the teachers were younger, and 44 were older. Cumulative relative frequency graphs. Let's try some examples because the best way to learn stats is to actually do it. So below is a cumulative relative frequency graph of the length in minutes of 200 songs recorded by the Rolling Stones. We want to know what are the median and interquartile range of song lengths. Draw the lines on the graph to show how you arrived at your answer. So I'm going to go back to my dot cam so we can actually work on this one together. All right, so here we have our data. And we want to show where is the median. So remember, the median is the 50th percentile. So 50th percentile. So I want to find where would 50% be. And I'm going to draw my line in between the 4 and the 6, which is right there. See where it touches my graph. And then I'm going to draw a straight line down. And you can see that the song length is between 3 and 4, but much closer to 4. Much, much closer to 4. Hang on 1 second. I realize my AC just turned on. It's going to get really loud. Sorry about that. Next, it's going to ask for the inner. So the median, or the 50th percentile, is going to be at around 3.8, and I'll put just about minutes. Now, another important thing is the IQR. So we're going to look at the inner quartile range. So remember, the inner quartile range is going to be the 75th percentile minus the 25th percentile. So let's look at the 75th percentile. Again, we're going to find on our graph where exactly the 75th percentile is on our frequency. So it's going to be between 6 and 8. And then in between that halfway mark, so it's going to be probably around here. That might be a little high. And then from there, we'll go straight down. Which looks like it's about 4.75. Now, Jediah asked earlier, how can you find percentile in large data sets? This is a pretty large data set. We can use a relative frequency graph to figure that out as well. And our second one is the 25th percentile. Because again, we're finding that IQR, which is 75th minus 25th. So 25th is going to be somewhere down here. Or sorry, up here. So we'll draw our line, see where it hits, go straight down from there. That looks like about 3.5. Subtract the 2. The IQR is going to be 1.25 minutes. So really, really important that we take time to go over relative frequency graph. I have another one here later at the end of the session. If you want more practice with cumulative relative frequency graphs, just ask the question below. And I have another one right here ready to go. But for now, we'll keep the ball rolling and do our next big topic. So far with our big topics, we've covered it and percentile, cumulative relative frequency graph. The next big one is z-score. Z-score is going to be huge, especially for my students. I'm always asking z-score questions because it's so important to statistics and moving forward in our school year. So what exactly is z-score? So the z-score tells you how many standard deviations from your average your data point is. And that tells you the direction as well. So if you're 1 standard deviation below your average, z-score will tell you that. If you're 1 standard deviation below, z-score will tell you that. So here's actually the formula for z-score, or standardized score. It's going to be your data point minus the average divided by the standard deviation. Here is its shorthand. So we take z equals x, which is your data point, minus x bar. Remember, x bar is the average of your sample. And then sigma is going to be your standard deviation. So z-score is great to figure out, like, where do I lie in terms of percentile for my class, for my high school. Where do I fall? ACT versus SAT, we're going to learn about that in a minute. Right now. So here's a great example. ACT versus the SAT. So actually, before I was at Fiveable and before I was at the school that I am at now, I worked for a private company in Newport Beach where we provided SAT and ACT help to students all over Southern California. And students always ask me, Mr. Durkin, which one should I take, the SAT or the ACT? And in reality, no one's going to score that much better on one of the tests than the other, but you might score a little bit better on one test depending on your personality and how you've experienced math in the past. So we're going to dive into Like, how would I rank myself if I get this score on the SAT and this score on the ACT? How does that compare? So what we're going to do now is go back to my .cam, and we're going to take a look at our SAT. So here are our SAT questions. So it says there are two major tests of college readiness, SAT and the ACT. ACT scores are reported on a scale from 1 to 36. And we have an average of 20.9 and a standard deviation of 4.8. The SAT scores were from 400 to 1600 with an average of 1026 and a standard deviation of 209. So again, we need standard deviation, we need average. Those are the two things we need to find z-score. Jose scored a 1287 on the SAT. Assuming that both tests are measured the same thing, what score on the ACT would give Jose an equivalent value? So first of all, we have to know what his z-score or standardized score is on the SAT. And let's not forget what the formula is for z-score. So z-score equals your data point minus the average divided by the standard deviation. And in this case, we know the average of the population, so we're going to call it mu. Remember, x bar represents your sample mean, and mu represents your population mean. That's going to be really, really important on the AP exam, especially the free response section, because if you write the wrong letter, they will dock you points. Okay, so what was Jose's data point? Jose's data point was a 1287. So then I'm going to say z equals 1287 minus the average. So for SAT, the average was 1026, and I'm going to divide that by 209. Sorry about that. Having some technical difficulty. That's literally never happened before. Let me unplug this and plug this back in. All right, I think it's good. So we're going to go to our calculator. Let's take 1287, subtract 1026, and divide that by 209. So we get a z-score of 1.25. I'm going to round that. Great, but that's not what the question was asking. The question was asking, what would the equivalent score on the ACT be for Jose? Well, we know our z-score, so we're going to use that. We don't know what the score is for Jose, so we're going to leave an X there. And we're going to subtract the ACT mean, which remember, it's only from 1 to 36, which is a 20.9. And we're going to divide that by the standard deviation of the ACT, which is 4.8. And now we're just going to solve for our data point right here. So this is some old algebra. If you aren't strong at algebra, let me know in the comments. And maybe one of these live sessions, I can just go over the basic algebra skills that you will need to access AP Stats. So the first thing we're going to do is undo division with multiplication. But whatever I do to one side, I have to do to the other. So those are going to cancel. And 4.8 times 1.25 gives me 6. So 6 equals x minus 20.9. I'm going to add 20.9 to both sides. And so I get the equivalent score on the ACT as 26.9. Now, whether you realize it or not, colleges are doing this because some teachers or some students do the SAT, some students do SAT, and some students do the ACT. So colleges need a way to compare to see who's better on that exam. All right. Now, there is something that we need to go into a little deeper with this problem. So number 2, reports on a student's ACT or SAT usually give percentile. There it is. There it is. As well as the actual score. Tanya scored a 1310 or 1318 on the ACT. What was her percentile? So Jediah, this is that question that you asked earlier about how do you do it for a large data set. So we want to find our z-score. So we're going to do the same thing. Z equals x bar minus the average divided by the standard deviation. So we're going to do 1318 minus 1026 and get 292. Divide that by 209. And we get a z-score of 1. I'm going to round it 40. Now I'm going to stop for a second because remember, this tells you how many standard deviations away from the average you are. So what this is saying is if we have our data and our average is 1026 with a standard deviation of 209, what percentile would this score be? So this is a 1318. So we want to know how much of the data is below this person, right? Because remember, that's what percentile means. How much of the data is below this data point? And we found out that 1318 is about 1.4 standard deviations above the average. So I'm going to bring something new, something that probably is going to be your best friend. And this right here is your Z table. So I'm going to cover this up real quick. It tells you the probability or percentile of the students who fall below that number or data points that fall below that number. You can also use your calculator, which we'll do in a second. But for right now, we're going to use our table. So we want to look up on the left side 1.4. So it's right there. And then up here is going to be our tenths or hundredths digit. I'm sorry. So since it was 1.40, our number is going to be right there. I'm going to go ahead and circle it. So that tells us that if we're looking at this data set, the percent that falls below is 91.92%. So 91.92% of the data falls below Tanya's score. So again, Jediah, you asked that question about how do you find percentile in a large data set, which was a great question. You use z-score. So z-score can tell you percentile, probability, and how many standard deviations from the average you are. Super important. Let's go to question 3, because there are many ways you can ask a standardized score question on the AP exam, and they're going to do all sorts of ways. There'll probably be like 2 or 3 that just ask you multiple choice, find the z-score, or using this z-score, what would the percentile be? So let's look at number 3. Number 3 says the quartiles of any distribution are the values with the cumulative properties. That should sound familiar. Cumulative relative frequency, cumulative properties. Remember, this is Q1, and that's going to be Q3. What are the quartiles of the distribution of ACT scores? So I'm going to go back and draw that normal curve. So here is our average. We want to know what score would give us 75% of the data below it. So what score would that be? And what about the score Q1, or the 25th percentile, would be below it? So we have to find the scores. So again, we're going to use the average, which was 20.9, and the standard deviation, which was 4.8, to find this out. And let's not forget z-score equals that. All right, so to get this, we need to know what is the z-score for the 25th percentile, and what's the z-score for the 75th percentile. So we're going to go back to our table to find out. So the 25th percentile is actually not going to be on this side of the data, because we know that the 25th percentile is actually below the average. So I'm going to flip this page over, and you're going to see a bunch of negative z-scores. This is a good time to tell you, negative z-scores mean it's below the average. Positive z-scores mean it's above the average. This is a helpful tip, that if you see a multiple choice question and you see that your data point is above the average, and you see multiple choice answers that have negative z-scores, they cannot be correct, because our data point is above the average, which is going to produce a positive z-score. All right, so that will save you a little bit of time when you're answering multiple choice questions. Also, it's a great way to check your answer. All right, if you know your data point is above the average and you get a negative z-score, you know you did something wrong. So right now we're going to look for the 25th percentile on the inside. So in here, we're going to look for the 25th percentile and find the z-score that correlates with that. So I see 15. I need to go more. I see 24. I see 25.15. 24. Okay, so it's somewhere in between here. Now all we want to do here is just pick the closest one to our data set, or to 25. So the closest one is going to be this right here, which is negative 0.67. So we want to use this and this. So row and column. So going back to our, we know this score is negative 0.67. Now let's find the 75th percentile. Again, we know 75th percentile is not going to be below the average, but it's going to be above the average. So I'm going to look, 75th percentile, it's going to be right there. Ooh, what do you notice? It's positive, 6.7. Very interesting. Positive 6.7. All right, why is that? Why are they the same? Well, let's think about this. if the middle is the 50th percentile, and this is 25% above, and this is 25% below, it's the same distance from the average. One's in the negative direction, and one is in the positive direction. So that's why you're going to see the same z-score, just negative and positive, for this question. So now we got to find the data point that's associated with those. So let's go over here. Let's do the negative one first. I don't know the data point, but I do know the average divided by 4.8. And again, I'm going to multiply both sides by 4.8. I'm going to do this just to save us a little bit of time. And then add 20.9. So I know that that data point is 17.68. So over here, 17.68 is going to be the data set for that number. Or I'm sorry, it's going to be the 25th percentile for the SAT. So anyone who scores a 17.68 on the ACT is going to be scoring better than 25% of the population. So it's the 25th percentile. Now the complement is also true, that they scored worse than 75% of the people. To find the upper bound, we're going to use the positive 0.67. So we're going to do the same thing. And we get 24.11. So on the upper end, 24.11 is our 75th percentile. Now again, that means that if you score a 24.1 on the ACT, you scored better than 75%, but worse than 25%. And again, that makes sense because in the middle is 20.9, I'm sorry. 20.9. That's z-score. We're going to spend lots more time on z-score. I actually might do a whole session on z-score because there are so many different ways that you can ask this question, and using your calculator is going to be extremely beneficial on z-score. Just to give you a quick preview, second VARs, normal PDF, these top three are all going to help you out with z-score. You're not going to need to do this anymore. It's all going to be here, and I'll teach you about it next time. All right, let's go back to our PowerPoint. I see we're coming up to time. I think I'll just do another session on this because it's so important. The last thing we'll talk about is transforming data. So the last thing we'll talk about is transforming data. Again, ask questions if you have them. Please, please, please. That helps keep the conversation going. So this might be something you want to screenshot or watch later. But if you add the same number to each observation in a data set, it's going to change a couple things. The first thing it's going to change is any measure of center. So your average or your median. It's also going to change the location of the different important parts. So it's going to change where your median is. It's going to change your quartile. It's going to change all your percentiles. But it's either going to move it up or back, depending if we're adding or subtracting, by whatever amount you added or subtracted. It is not going to change the shape or the measures of spread, so how spread out your data is, like the range, IQR, and standard deviation. I'll show you a concrete example of this, and it'll make total sense. Last but not least, multiplying or dividing an observation by a number is going to do a couple things. First thing it's going to do is it's going to change the center and locations by a multiple or a dividing by whatever number you have. The second thing it's going to do is it's also going to change the spread. But it's going to change it by the absolute value of whatever you divided by or multiplied by. That's super, super important. I would highlight that. There may be one question or two questions about that on the AP exam. Definitely going to be some on my personal exam. So for those of you that are watching from my class, definitely expect it. The absolute value is going to be there. And it's not going to change the shape. So the shape is still going to remain the same. So let's dive into a quick example. So if you have your calculators, go ahead and take those out. And you can do these calculations along with me. Okay, so here are some test scores that I calculated from my Algebra 1 class. And if you remember from our last session, we talked about how we can enter that into the calculator. Just for those of you that weren't here, here's a quick review. Open your calculator and hit the Stat button. Edit. You have a bunch of lists. To clear your list, you're going to go to the top, hit Clear, Enter, and then you can type in your data points. So 61, 65, 65, 73, 75, 77, 78, 78, 79, 80, 80, 80, 80. And you're just going to keep going. Okay, 20 data points. Perfect. Now to run the data on this, to get this information, which I guess you can't see, we're going to go Stat, Calculate, one variable statistic. Where did you enter in your data? I entered into L1 and enter. So for the sake of this, since I already went over this in our last session, again, go back and watch the other one if you need help with the calculator. But here is our data. Okay. If I said, you know what, I messed up on this test, and every single person is going to get 2 more points. I'm sorry, it's freaking out. Let me try unplugging it and plugging it back in. Oh. Okay. So if I said, you know what, I'm going to increase every data point by 2. So I added 2 here, 2 here. So that was now 63, 65, and so on. Let's see how it would change my data. So let's plot our data. So that's what it looks like. Now I'm going to take my data set, and I'm going to say, okay, take L1 and add 2 to every data point. And there we go. So you see how it's all added up? Super sorry about this. Not sure why it's freaking out. Let me unplug it and plug it back in. Okay, a little bit better. So all my data points now have 2 added to it. So let's go Stat, calculate one variable. So Stat, calculate one variable statistic, L2. And look at that. So our old data set had an average of 80. Our new has 82. Our old data set had Q1 at 76. Our new one has it at 78. So all it did was shift it up. And let me show you what that looks like on a graph. There it is. It's just shifted up 2. We would see something very similar if and the range is the same, right? Our range is still the same. It's just been shifted up 2. I'm having a little technical difficulties, so we're going to call this one a little early. Thank you for sticking around and watching this. I appreciate it. Tune in next week where we will dive more into z-score, transforming data, the normal curve. Please, please, please ask questions, send emails, tell your friends. The more people we get on this session, the more chats we have, the better our live sessions are, because I get to interact with you guys in a way that's more beneficial to you. So my job is literally here to help you. And so when you're asking me questions, I can more targetedly help you. So please, please, please ask questions. Go back, watch the old sessions for up-to-date calculator tips. I'll figure out this technology stuff. I didn't have any issues the first couple times, but we'll work it out. So if you have any questions, I'll stick around for a couple more minutes. If not, tune in next week where we will dive more into the normal curve. Jediah, this is what we're going to cover next week. So my video is all about it, as well as the homework and quiz. We'll have a quiz coming up. All right. Well, if no one has any questions, thanks for tuning in, and we'll see you next time.